In this video, I'm going to look at some problems involving periodic sequences. So we've got a sequence written here, and we need to find the sum of the first 20 terms. Okay, so what that means is essentially we need to add up the first 20 terms, and then the result is my answer. Okay, but sitting there manually adding up every single term up to and including the 20th one, that's going to take a lot of effort. We want to think about a quicker way. Well, if we look at this sequence here, it appears to be repeating every 4 terms. Okay, we've got -2, 7, 3, and 5, and -2, 7, 3, and 5. Therefore, the period of this sequence is 4. Okay, it's a periodic sequence. We can say that un is equal to the term 4 terms later, say un plus 4. And this is going to help us quickly figure out the sum of the first 20 terms. Because what I can do is take one period, which are these 4 terms here, and let's add them up and see what we get in one period. So we'd have -2 plus 7 plus 3 plus 5, like that. Okay, and that's going to give me a result of 13. So what we figured out here is that every 4 terms have a sum of 13. Okay, so the terms from the first term to the 4th term have a sum of 13, then from the 5th term to the 8th term have a sum of 13, and so on. So let's now have a go at using this bit of information we figured out over here in order to calculate the sum of the first 20 terms. Okay, so essentially what I need to think about is how many times can I get a full set of 4 terms into 20 terms. So let's do some division. Okay, what we're going to do is do 20 divided by 4, and that comes out as 5. Essentially, we have 5 full sets of 4 terms within 20 terms. So if I want to find the sum of the first 20 terms, well, that is going to be equal to 5, the number of sets of 4 terms we have, multiplied by the sum of every 4 terms, which is 13. So the answer would be 65, like that. Let's have a look at the second one. So the second one says 31 terms. Okay, so let's figure out how many full sets of 4 terms can we get into 31. Okay, so this time we are going to do 31 divided by 4. Now 31 is not divisible by 4. So what we're going to do is write our answer in terms of our quotient, our whole numbered part, and a remainder. Okay, because we can get 4 into 31 7 times, and the remainder would be 3. So therefore we have 7 full sets of 4. So if I'm trying to work out the sum of the first 31 terms, I need to do 7 multiplied by the sum of each 4 terms, which is 13. However, that's not my final answer because we have 3 terms left over. So I need to add on an additional 3 terms. Okay, so I'm going to go to one of my periods and take the first 3 terms. So if we go from the start of the sequence, we have -2, then 7, then 3. Okay, so I'm going to add on -2 plus 7, and then plus 3. Okay, and then this calculation here is going to give me my final answer. So 7 times 13 is 91. So that's what I get from my full 7 sets of 4 terms. And then what I need to do is add on these other 3 terms. So we've got -2 plus 7, which is 5, plus 3, which is 8. So I need to add on an additional 8. So that's going to give me an answer of 99. So that's how you efficiently as possible answer a question like this. So here's our question. We're still dealing with the same sequence as before, so I've got the key information written out on the right. Now it says, how many terms does it take for the sum of the sequence to exceed 223? Okay, so this time, instead of figuring out what the sum of a certain number of terms are, we're essentially given the sum, and we need to figure out how many terms does it take to get there. So we need to figure out the first term for which the sum will exceed this value here. So what we're going to want to do is still make use of this bit of information up here, the fact that the sum of every 4 terms is 13. And what we're going to do is figure out how many 13s can we get into the 223. How many full sets or 4 terms can we get in there? So we're going to do 223 divided by 13, and we're going to stick that into the calculator. And we get 17.2 to 3 significant figures. So what does this tell us? Well, it tells us that we can get 17 full sets of 4 terms into 223. So let's do 17 times 4. Okay, and 17 multiplied by 4 gives me 68. Okay, so we've got 68 terms so far, but let's see what number 17 full sets of 4 terms actually gets us in terms of the sum of our sequence. So let's also do that 17 multiplied by the sum of every 4 terms, which is the 13, and see what we get. Okay, so 17 times 13 gives me 221. So unsurprisingly, we are still below the 223, because here it says that to get 13 into 223, okay, we get it in 17.2 times. So we still need to essentially deal with the 0.2. Okay, we still need to get to 223 and exceed it. So what we're going to do next is take the sum so far, which is 221, and we're going to add on the next term in the sequence. So we're going to do 221, and the next term would be negative 2, because essentially we've got 17 full sets of 4 terms. So we're now going to start a new set, which starts with negative 2. So if I subtract 2, I get 219. Okay, so we still haven't exceeded 223. So I'm going to have to add on the next term. So let's do 219 plus the next term along, which is 7. So we're going to add 7, and then that's going to give me 226. And now we have finally exceeded 223. And in order to get there, we had the initial 68 terms, which are the 17 full sets of 4, plus another term, which was the negative 2, plus another term, which was the positive 7. Okay, so we got 68 plus 2, which gives us 70 terms in total. Therefore, it takes 70 terms in order to exceed 223 as the sum of my sequence. We're now going to look at a slight variation of the previous question, because I do have a warning to give you. Now, if we look at our sequence, it looks very similar to before, but what I've changed is that instead of having a positive 5 here, I've got some negative 5s instead. Because what you'll find is when you answer a question like this, the more negatives there are in there, the more tricky it actually becomes and the easier it is to make a mistake. So it still asks, how many terms does it take for the sum of the sequence to exceed 223? Well, let's take the same approach as before. This sequence still has a period of 4. So let's figure out what is the sum of every 4 terms. So let's do negative 2 plus 7 plus 3 plus negative 5. Okay, and that gives me a total of 3. Therefore, every 4 terms has a sum of 3. So what we would then do is figure out how many times could I fit 3 into 223, because that's going to tell us how many times we can get a full set of 4 terms before we exceed 223 as the sum of our terms. So let's do 223 divided by 3, which is the sum of every 4 terms, and that gives us 74.3. So that would imply that we can get in 74 full sets of 4 terms before we reach 223. So let's actually calculate what the sum of 74 full sets of 4 terms actually is. So we'd do the 74, which is how many full sets we have, multiplied by 3, which is the sum of every 4 terms. And that gives me an answer of 222. So we've not exceeded 223 yet, so we clearly got to go and add on an additional term. Actually, what we have to consider is the fact that the last term in our period is a negative 5. Okay, therefore, when I've added on the term to complete my 74th set, I've subtracted away 5. Okay, so I've actually reduced the sum. So let's reverse that. Let's go to the 222, okay, and let's add 5 back on, and that takes me to 227. So actually what we'll find is before we had 74 full sets of 4 terms, we had already exceeded 223.
So what I would suggest doing is instead of using 74 when you've got negative numbers in your sequence, is use a number less than 74. Okay, so the next logical number to choose would be 73. So let's investigate 73. So instead of doing 74 times 3, we're going to do 73 multiplied by 3. And let's see what that gives us. Well, that gives us 219. And let's think about whether this value makes sense if we go back 1 term. Well, once again, if I was to add 5 to the 219 to counteract the negative 5 in that last term in the period, well, I would get 224. So it's clear that we've already exceeded the sequence there as well. So therefore, using 73 wasn't the correct decision either. Let's go one less and let's use 72. So 72 multiplied by 3, well, that would give me 216. Okay, now if I was to go one term back and add on the 5, well, I get 221, which is less than 223. Okay, so it seems that we made the correct decision this time. Okay, so let's start adding on terms until we exceed the 223. So we'd add on our first term in the period, which is negative 2. So 216 plus negative 2. Well, that gives me 214. So that's actually made our sum less. Now let's add on my next term. So we're going to add on 7. So 214 plus 7. Well, that gives me 221. That is not greater than 223, so I have to keep going. So now let's add on the 3, which is the next term. So 221 plus 3. Well, that gives me 224, which does exceed 223. So it seems that we've got to where we want. So now let's figure out how many terms it actually took us. Well, we use 72 full sets of 4 terms. So we need to do 72 multiplied by 4. But then after that, we added on the negative 2, the 7, and the 3. So we added on a 3 further terms. So I need to add 3 to get my final answer, which would be 291 terms in total. So that's how many it takes to get the sum exceeding 223 for the first time. Now let's look at a different application of periodic sequences.
So we've got a sequence of terms which are called A1, A2, A3 and so on. And we have the recurrence relation defined here. We need to find the value of this here. So what does this actually mean? Well, when it's written AN, that's just referring to the sequence. Okay, so that's the sequence above that was described in the question. Now this symbol here is sigma. Okay, and sigma represents summing. Okay, it means sum. So essentially this is asking for the sum of a sequence. So then the question is, which terms in the sequence does it want me to sum? Well, that's indicated by the n equals 1 and the 85 at the top. The n equals 1 represents the position of the first term in the sum. So in this instance, the position of the first term in the sum is the position 1, so it is the first term in the whole sequence, which is written up here, it's the 3. And then the 85 represents the position of the last term in the sum. Then what this whole calculation is representing is the sum of the sequence from the first term up to and including the 85th term. Okay, so we need to essentially sum the first 85 terms of the sequence. Okay, so right now we only have a recurrence relation, so we have no real choice but to start writing out the terms of the sequence. Okay, because I don't recognize this as a specific type of sequence like an arithmetic one or a geometric one, which we do have some formulae for summing. Okay, so we're just going to have to start writing out the terms. So we know that A1 is equal to 3, that's given in the recurrence relation. Now what about A2? Well, this is saying we're going to do 8, subtract the previous term to get the next term. So 8 subtract 3 gives me 5. Okay, so that will be the next term. And then to get the term after that, A3, well, we're going to do 8 again, because that's always in my recurrence relation. And then we're going to subtract the previous term. So we're going to do 8, subtract the 5, okay, and then we get 3, okay. And we know that when we substitute 3 into our recurrence relation, okay, we get 5, because we already did that here. So therefore, we've established this is a periodic sequence, and it's going to be repeating every 2 terms. Okay, so I can say that the period is equal to 2. And this is going to help me sum my sequence, because we know our sequence goes 3, 5, then 3, 5, and so on. So we know each pair of terms have the same sum. So let's figure out the sum of a pair of terms. Well, it's going to be 3 plus 5, which is equal to 8. Okay, so what we've established is that every pair of terms sums to 8. Now let's try and make use of this to calculate the sum that we were actually asked for. So we were asked for the first 85 terms. So what I need to do is take 85, the amount of terms that we want, And we're going to divide by our period 2 to figure out how many sets of 2 terms we can get into 85. So that would give me an answer of 42 whole times, and then there'll be a remainder of 1. Therefore, if we want the sum of our sequence, so we're going to write it out here. So the sum of an from n equals 1 up to n equals 85, then this is going to be equal to 42 multiplied by 8, which is the sum of every 2 terms. And then we still need to add on one additional term. Okay, so if we look at our sequence, our first term is 3. So we're going to add that on as that's the start of every pair. And then that calculation there is going to give me the full sum, which is 339. And that's my final answer.